Hello, my dear students. Welcome back to our channel, PUC Karnataka. In this session today, I'll talk about your chapter of second PUC, which is matrices, right? So we'll look at questions of both the styles. We'll look at for second PUC as well as KCET. I hope it makes sense. Why this chapter? Of course, because we are going in sequence. We have done already one shot of relation and function. Then we did inverse trigonometric function, and now we are moving to the third chapter of our syllabus, which is matrices, the matrix. Great, sir. Understandable. Why this chapter is important for us? Multiple reasons. This is basically, a chapter where you can score very easily, very freely, right? The concepts over here are not that complicated, and it has good amount of weightage in boards as well as CET. In CET, close to 4 questions come from here, 4, sometimes 5 also. So that is in CET weightage, okay? And again, when I say 4, 5, I don't mean, like 4 used to come or it was 4, 5 years back. No, the last year paper, if you go and check it out, you'll find minimum of 4 questions from this chapter. I think it was 5, but let me just be safe and say minimum of 4 questions came from this chapter in CET 2026. How is that? Okay. And for boards, again, 8 marks, 9 marks, something like that is the weightage for this chapter as well. So you can understand importance is there. Very easy chapter. We'll look at this and we'll complete everything all together in this session itself. We'll practice questions of both the categories and we'll look at all the concepts. So what are the major concepts which is there in this chapter? So CET's favorite concept is transpose of the matrix. Yeah, the skew symmetric wala part, the properties wala part are very important from the CET point of view. What about board, sir? For board point of view, again, transpose matrix and properties alongside the matrix multiplication is the favorite part. There is actual 5-mark question that comes almost every year in your boards on the matrix multiplication. You can find that in the last n number of years of PYQs, okay, and also you can find the same in the question bank, and they're all pretty easy. We'll look at that in detail. I hope this is clear what we're going to do today in the class and why we are doing it. I think your time is important. I've already taken too much of it. Let's start the class right away with the small definitions and understanding of what is a matrix. We'll start from the very basic and then we'll build up to the level of CET. Okay, sir. Definition point of view. So matrix is something, basically arrangement of row and columns. Means when you fill the data in this empty spaces. Okay, this is a rectangular array of numbers or functions in horizontal and vertical lines. Okay, and again, of course, the horizontal lines are called as rows and the vertical lines are called as columns. Okay, the vertical lines are called as, this is over here, you can see. One second, let me just highlight it better. Rectangular array, alongside, of course, you have the rows and columns. Okay, so matrix can be of both the nature where the number of rows and columns are equal. Okay, so basically this number of row, this value which is called as number of rows and number of column, this particular value together is called as the order of the matrix. Means, let's say a matrix has 2 rows and 2 columns. We write it like this, 2 cross 2. This represents rows and this represents column. Of course, you all know that it's not difficult. So we can have different variety also. We can have 3 cross 4, let's say. You can see here, this is again for rows and this right one is for columns. So we can have 2 possibilities where the number of rows and columns are equal, not necessarily always 2. It can be 3 cross 3, 4 cross 4, but in our syllabus we have maximum up to the 2 cross 2 or 3 cross 3 matrix. Okay, for the square side, this is called a square matrix. Don't worry, we'll look at that. And 3 cross 4 is for rectangular matrices. Okay, so let's move on. So what is order? When you write number of row and number of columns together, again in the same order. First you write what? The rows and then column. That is the order of a matrix. We have different types of matrix. Okay, simple definitions are there. We can quickly go through that. Row matrix, a matrix which contains only one row. And how many columns? It can have one column or multiple. That is not important. But row must be only one. For example, I take this as the, let's say, element. It has one row and only one column. One row and only one column. But if I go and write, let's say another matrix with 2, 5, 8. 2, 5 and 8. Now this one has one row but 3 different columns, right? So a row matrix, what is important over here? Remember, number of row is always same. Number of column is one or more. That is not important. Okay. Now for column matrix, just opposite in column matrix. Where number of column is 1 and number of row can be more than 1 or equal to 1. Null matrix. Now this is very beautiful. What is this? The null, whenever you see, what comes to our mind? The word 0. The word 0. So where each element of the matrix is 0, that is called as null matrix. And we'll see it is very useful, very commonly used in our lot of questions and problem solving. Square matrix. This is what I was talking about. When the values are equal, for example 2 cross 2, 3 cross 3, 4 cross 4. When this order values, basically number of row and column values are equal, it's called as square matrix. And in this case, what we write usually? N cross n as the symbol. Means number of row is n and number of column is also n. I hope it makes sense. Again, bacha, you can download these notes to find it. It will be very, very useful to your preparation for whether you are preparing for FAs or midterms or finals also. The notes will be very, very useful. So if you are somebody who's seriously looking to improve your maths or seriously looking to prepare for second PUC or KCET, you have to do only one thing: have the notes with you for these one-shot lectures, and of course watch it multiple times. Not just watch it, solve the questions that I'm giving you. So the questions that you're solving in the class, are they enough? You might have this doubt, right? Sir, the questions you're solving in the class, are they enough? My answer is of course not. We need to solve more questions. But sir, you are solving here, let's say 10, 15, 20 questions. How will I find more questions, right? So the answer of that problem lies over here. Let me tell you about that. We have launched something called as AIO. It's our next gen, learning platform. It is a next gen learning platform. Okay. In this platform, beta, you're gonna find all these lectures. So whatever you have on YouTube, all the lectures, recorded, live, all the lectures will be present in this platform. So you'll find over here what, sir? Lectures. So if any serious student is coming to me and asks me, sir, how do I study? What I'm gonna say first thing, beta, watch the lectures. Yes, sir, lectures are done. First thing is been taken care of. What is the next step? Notes. Yes. So in this platform only you're gonna find what? Notes also. The teacher's class notes will also be over here only. Lectures are there, notes are there. What next? Doubt solving. Yes, you'll find over here doubt solving also. In this platform, you'll have access to our own intelligence, which is Ved, which can help you solve multiple doubts. So you can see in our one next gen learning platform, it's called as AIO, all in one. What does it means? This has a meaning, all in one. So in our platform, you'll find all of this. But sir, the point, you said questions also. Yes, you'll find here questions also. Will give you extra problems to practice, beta. Will give you this as well to practice. And what is the beauty of this thing? This all is free of cost. No charge at all. Of course, means all of you who are learning from us, from Diksha Vedantu on YouTube, you can simply access our all-in-one platform and get all these features for free. How to do that? Let's look at that also. So if you check any of our lectures on YouTube, this is our channel, right? Diksha Karnataka. If you check any of our lecture on YouTube, any lecture you check, for example, let's say this is my upcoming live. I will go and check it out. So in this upcoming live, if you go and check the video description, the sessions, the lectures description, you'll find written over here, join the free ACE KCET 2027 batch. Course. Click on that and this page opens. This is your all-in-one page. Over here You'll have the title as Prime Course ACE KCET 2027. Move forward, click on buy now. Sir, buy now. No cost. There's no charges. Okay. Simply click on buy now, and you have to create, your login credentials. Means how can you access your learning platform? So create that using basically numbers, OTP, whatever it is suitable for you. Create that. Once that is done, you'll have the platform in front of you. You can select the course and start learning right away from there. Okay. So all the lectures which is available on YouTube, right, is available over there also. But the point is that is a learning platform. Okay. So a lot of features, all these features are available over there. I hope it makes sense to all of you. Yes. All right. And again, this is also free bit, no charges. Right. So I hope this is clear. Achha, let's discuss few things that I missed. Yes. Square matrix. Okay. Now there's something called as diagonal and non-diagonal element. So what is square matrix when the number of row and column is same? Let's look at an example now. Let's say this is a 3 cross 3 matrix. Elements are 1, 4, 2, 5, 3, 9, 2, 4, 8. 9 elements. In a matrix of order 3 cross 3, you'll have how many elements? 3 rows, 3 columns, so 9 elements. Okay. So this is your rows and these are the columns. Yes, sir. So whatever element comes at this position, AII or AIJ will call, when I and J are equal. What's the meaning of I and J, sir? Because the first position is called as, this position is called as A11. Same as this position is called as A12. This position is called as A13. How do you write that? Address of the position means which row and which column it is contained in. First element you check is present in first row, first column. This element, first row, second column. This element, first row, third column. Even if you're watching me later recorded, please repeat after me. Which column is this? Which is the address of this particular element? Second row, second column. Correct. What about this one? Third row, third column. So what I was talking about is whenever you have an element Aij, provided I and J are equal, those elements are called as diagonal element of what? Of the square matrix. Acha, this will not be present in a rectangular matrix. What is rectangular matrix, sir? Wherever you have number of row and number of column not equal, then this property will be not true. This will not be there. Okay. So diagonal matrix, diagonal element is true only for the square matrix. And what are diagonal element? What are diagonal element? Please check. Is over here. This right here. In this case, you'll have 1, 3, 8. A11, A22, and A33. Right? That's what it is. So this is called as non-diagonal element, means everything else. So 4, 2, 9, 5, 4, 2 are non-diagonal element. Whenever I and J are not equal, it's called as non-diagonal element. Okay. When it is equal, it's called as diagonal element. For example, check it over here. And in a matrix where the non-diagonal element are 0, for example, 4, 5, 0, 0. Can you see? This is a square matrix of order 2 cross 2. This one is diagonal element and this one is non-diagonal element. Now you will say, sir, what about sir, if you write a square, if you draw a square, we have two diagonals now, sir, this one and this one. This one and this one, right? You might have this doubt. Sir, if it is a square, okay, we have two diagonals, this one and this one. Why are you calling this only as diagonal? And why not? Because I didn't say diagonal of the square. I said diagonal element means when for the element Aij, I should be equal to J. Let's look at this element. You'll have A11, A12, A21 and A22. Across this 2, you have I and J same. I is 1, J is 1. I is 2, J is 2. What about this one? Is it same, beta? It's not same. I is 1, J is 2. I is 2, J is 1. So across this one, you're finding I is not equal to J. And over here, you're finding I is equal to J. And for that reason, it is called as diagonal elements. Diagonal elements or diagonal, basic diagonal of the square matrix given to us. I hope this is clear. And for any square matrix, if you have non-diagonal elements, which is these two, in this case, which is 0, then the matrix becomes a diagonal matrix. So whenever you have non-diagonal element as 0, that will become a diagonal matrix. Okay, this is important. Moving on, building forward. Okay, this is regarding your AIO update, right? How can you access and everything? Everything you'll find over there only. Okay, please go and check the platform. Get used to it. Start learning from there. Now, these two are also diagonal element. How come, sir? Start from here. When I have, sir, 4, 5, 0, 0. This is what? Diagonal matrix. When I have, sir, 4, 4, 0, 0. When they are equal, when the diagonal element is not only, of course, when the non-diagonal element is 0, but across, also the diagonal elements are equal, then it becomes scalar matrix. What happens when it is 1, 1? So it is equal, but also equal to 1. The diagonal elements are equal. Is it not equal? Equal, right? But it is also fixed to 1. That's called as identity matrix. So diagonal matrix, scalar matrix, and identity matrix looks like this. I've taken the example to show you. Again, definition and all you will find it over here in the notes. Now we are moving to lower triangular matrix. A lower triangular matrix. A square matrix in which each of its element above the diagonal is 0. What it means, sir? So if I take example of 2 cross 2 matrix, it means if it is 2, 4, 3, this is 0. Square matrix, yes sir, 2 cross 2, in which each of its element above diagonal, this is diagonal, sir. Above means this one, and that is what? 0. If you have a 2 cross 2, 3 cross 3, let's look at example of 3 cross 3 also. 2, 7, 8, 4, 1, 3. 4, 1, 3. This is 0, 0. Same result. This is my diagonal, and these all elements are 0. So if you find beta above the diagonal, all the elements are 0 in a square matrix. Don't forget, in a square matrix, then it is called as lower triangular matrix. It is called as lower triangular matrix. Sir, it is important? Yes, it is important. It is very important actually. Okay, it makes our life easier in calculations, especially in competitive examination problems. Because there's a property regarding both of them in determinant. We'll learn that there. Upper triangular matrix. Exact opposite. Okay, so if I call this as lower triangular matrix, this will become upper triangular matrix. How will this work? I think you can all guess now. So if I take over here 2, 7, 8, this will be 0. Can you see? This is diagonal, and the element below this is 0. 3 cross 3, if I check, 2, 1, 5, 2, 1, 6, and this is what? 0, 0, 0. So the diagonals, okay, diagonal create the partition, and if the below, all the elements below the diagonal is 0, it's called as, upper triangular matrix. Clear? Moving on. Comparable matrices. This is very simple. If you have same number of rows, same number of columns, that means same order. If two matrix is having the same order, basically what it means, if the matrix A has the order m cross n, and matrix B has the order also m cross n, that becomes what? Comparable matrix. Equal matrices, when the order is same as well as the element is same. So we have two things over here. Equal, it will be equal when it is same order and corresponding elements are also equal. Rectangular matrix already done when the row and column are not equal. The number of row and number of columns are not equal is rectangular matrix. Okay, let's look at some questions now. If a matrix has 24 elements, what are the possible dimensions or orders of this matrix? Basically, number of element in this matrix is what? 24. There's no symbol as such, it's just some writing for reference. Okay. So how would you identify the orders? Simple, sir. One row, 24 column. Because whatever elements are there, beta, we have to arrange them in what? Rows and column only. So either one row 24 column or other case 24 row 1 column. Next what? Sir, 2 row 12 column or 12 row 2 column. Next what? 3 row 8 column or 8 row 3 column. Next what? 4 row 6 column or 6 row 4 column. Any other possibility? The 7 we can't multiply. What about 8? 8 is a 24 already taken. So we have how many possibilities? Check here. 1, 2, 3, 4, 5, 6, 7, 8. Total of 8 possibilities are there. You can have total of 8 dimensions or 8 different orders. What is the answer? Number of orders or dimensions will be what? Equal to. This can be asked in MCQs also, guys. Okay. What if it has only 13 elements? Let's say another matrix is there which has 13. Then we have only two possibilities. 1 row 13 column or 13 row 1 column. So answer is 2 possibilities. Simple problem, nothing else. Moving on. Identify the type of following matrices. What is this? Zero matrix, null matrix, null matrix, right? Null matrix, clear, no? Then what about that one, sir? This is I can call this to be either diagonal matrix. So I can call, first of all, this is rectangular. If you want to write this as, you can write rectangular and then null matrix. What about this? You can write over here diagonal matrix. What about this other one? You can write this as also scalar matrix. So what is my final answer actually? My final answer is this one. I'm just giving you an idea. I'll give you the final answer also. What about this one? This is a upper triangular matrix. So my final answer looks like this only. Okay, the final answer over here also. This is the final answer. But I'm explaining you what are the different possibilities also there for these matrices. These two are square. This is a rectangular matrix. Examples. Number of 3 cross 3 matrix with entries -1 or 0. 3 cross 3 matrix. So 1, 2, 3, 1, 2, 3. That's the number of elements that you have. Now, if I look at this element, I can take 0 or not 0. I can take -1 or 1. And we know that if I take -1, I'll have a different matrix. Whatever is the other element, if I have over here -1, it will be a different matrix. If I have over here 1, it will be a different matrix. Right? For both the situations, I create two options. So first element can contribute in two ways or two different matrices. What about this element, sir? Also either -1 or +1. What I get over here? Again, two different possibilities. Does this being minus or this being minus depend upon each other? Does this being plus and this being plus depend upon each other? Does this being minus and this being plus depend upon each other? Answer is no. Why not no? Because they have not mentioned it to be 0, null matrix, scalar matrix, equal. There's no condition given as such. Okay, first of all, this cannot be scalar because it is not 0 or something like that. But if the element was 0, let's say 1 or 0, if the element was 0 or 1, here it is -1 or 0. For 1 second, assume this is 0 and that is 1. Then if you write here 0, this also 0, this also 0, what happens? It becomes a lower triangular matrix if this is non-zero value. but there is no condition as such. If you're confused, sir, how you're saying that putting some value over here will depend upon this. If you're confused right now, let's say you're confused, say that, sir, I take any value over here and that will affect what I'm taking over here. In what cases? Beta, in the cases where, let's say I have this matrix and to fill with 0 or 1. And if you take 0, 0, 0 here and this is all 1, this can be, if you take this as all 1, it becomes what? Upper triangular or lower triangular. If you take this as 1, 1, 1, or even if you take this as 0 over here. But if you take this all 1, 1 and you take 1, 1, 1 over here and you take 0, 0 here, it becomes upper triangular matrix. If you take all 0 here, please keep your mind open, okay, in the questions. Because you might be somebody who's writing JE also, you might be somebody who's writing CT as well. I cannot, give you, there's no chance of, improvement only in the question. There is, right? So putting an element over here will certainly be a different case if they mentioned the condition that the given matrix has to be only identity matrix or lower triangular matrix or upper triangular matrix, scalar matrix, whatever it is, or non-scalar matrix or non-diagonal matrix, right? For all these different cases, the question will change. Then that element we are writing 0 or 1 will depend upon, a minus 1 and 1 will depend upon what we are writing on to next to each other. Because we have to know the condition of the given boundary, given condition in the question. Over here, nothing like that. So let me summarize it again. In this particular question, in this particular case, there is no limitation. Means what I take at the second place or the third place, at the fourth place, at the fifth place, or at the ninth place will not affect what I'm taking at any other place. Getting it? Yes. And for each of the arrangements, you'll have different matrix. If let's say if this is my fifth place has 1. That is a different matrix. If I take this fifth place as minus 1, that is a different matrix. Means each element contribute in 2 different ways. How many times? A total of 9 elements. We have 9 times. Getting it? Each element contributes in 2 ways. And you have how many? 2 into 2 into 2 like that. So total 2 power 9. The answer is coming here. Option. I could have given you answer and moved on, but I wanted to teach you as well. Okay? Moving on. They're asking us to compare them because it is a comparable matrix. Order is 2 cross 2, here also 2 cross 2. So find the value of x, y, z. So we'll compare. From here, if you compare, what are you going to get? Compare means, so this is actually equal matrix given over here. This matrix over here, which has 1, 2, 3, 4 elements, this also is 4 elements, are equal. It means corresponding element is equal. So x minus y is equal to 0. So x is equals to y. First is this. Next, x plus y is equal to 0. Right? X equals to minus y also. Next, get from here. Okay. X plus z equal to 1. Now, if you add these two, this is my equation number 1 and equation number 2, add them. You get 2x equal to y minus y, which is 0. X equal to 0. And since x and y are equal, so x and y are both equal and they are both 0. So what is z value going to be? 1. So answer is what? 0, 0, 1. I hope it makes sense to all of you. Correct, na? X is equal to y, x is equal to minus y. Add them. 2x equals to 0. X is 0, y is 0, z is 1. Operation on matrices. Yeah. So in boards, the questions on this also is, there, where we talk about addition, subtraction, scalar multiplication. If not direct questions on these operations, but any other question of transpose or multiplication might use the application of these operations. They're very simple. Let's look at them. So again, addition or subtraction will happen only if the order is same. Not necessary it is always a square matrix. Just that order is same. So we can add 2 matrices, matrix A and matrix B, only when the order is same. Okay. I think you can find it over here written. Whenever the order is kept same, then the matrix becomes, you know, comparable or something that you can add. Okay? Two matrices which can be added are conformable for addition. Okay, and adding of A and B are not defined when A and B are not of same order. Okay, and whenever you add the corresponding elements, like you compared, right, the corresponding elements. Same thing you'll do in the case of adding also, and this is exactly the same for the case of multiplication, the subtraction. So if I take example over here, let's say 2 0 8 5, I have, this is my matrix A, let's say, and I want to subtract 5 9 3 1. Subtract them. 2 minus 5 is minus 3. 0 minus 9 is minus 9. 8 minus 3 is 5. 5 minus 1 is 4. So basically, you do what? You subtract the corresponding element provided the order is same. Here I have taken example of square matrix, but that is not always true. You can take for rectangular matrix also. Just that order has to be same. Okay, cool, great. Yes. Now let's look at properties of matrix addition. Properties of matrix addition. Property number 1. So if you are adding the matrix B to A or A to B, B to A or A to B, the result will not change, provided they are, of course, conformable, means they have the same order. So if A and B are having the same order, then we can add it. And if you have the condition true, it means you can add A to B or B to A. The result will not vary. The result will not change. Okay. So this is called as the commutative property, which is true for matrix addition. Next is associative property, which is also true for matrix addition. When you have 3 matrices, you can add the first 2 together, and then later you add third one to the result of the first 2, or you can add the second and third matrix together and then add the first one to the result of second and third matrix. That will also be same value in both the cases. You can take an example and try to solve it. Again, same order has to be there to be, suitable for addition of matrices. This is existence of additive identity. Existence of additive identity. For any matrix A, there exists a null matrix 0, which works in this way: A plus 0 is equal to A, or 0 plus A is equal to 0 is the additive identity for the matrix A. Property number 4. Existence of additive inverse. So there exists a matrix minus A. When you add A to minus A, this is called as additive inverse. And then you add A to minus A or minus A to A, the result will be a null matrix. The result will be a null matrix. This is important. Left cancellation law, or right cancellation law. Means if you have A plus B or A plus C, can you see that this A and A is on the left hand side of both the matrices? You can simply write B equal to C, because what you have done, you cancelled from the left hand side. And yes, in matrix it works like that only. Okay, so you have to cancel from the which side? Left hand side. That's why it's called as left cancellation law. And this is, can you see, A and A is equal over here on the right hand side of both the LHS and RHS. Means over here B plus A is there. This is on the right. Here also C plus A is there. This is on the right again. This is called as right cancellation. In case of numbers, it doesn't work like that. If you have 2 plus 3 and 3 plus 2, you can cancel. If you have 2 plus 3 and 2 plus 3, will cancel. But this works better. But will this work even in the case of matrix or not? It will work. Let's say this was written as, sir, A plus C. This is written as A plus C. And over here what we have? B plus A. Then can I cancel A and A? How? Sir, I can write A plus C as C plus A. How come? Commutative law. A plus C as C plus A. So basically this will become what? B plus A. Now you can cancel. Getting it? This works like that. So basically that is there, but there is a law behind it. It's called as left cancellation, right cancellation law. Next is scalar multiplication. This is something that you use a lot. So addition subtraction is basically, nothing different than what we have learned so far from very, junior grades. But scalar multiplication is something we use a lot, and it is also not difficult, but basically those will feel very automatic to you. Okay, very same. But scalar multiplication is something different, very useful, and also different in the case of determinant. 2 times of determinant of A is different as 2 times of, so basically 2 times of determinant of A is not equal to 2 times of. This doesn't work in the same way. This is not working in the same way as 2 times of matrix of A. In the case of determinant, multiplying 2 to determinant can be multiplied to any particular row or column, but any one. If you're multiplying 2 to a determinant of A, you can multiply 2 to any particular row or column, not to all. But in this case, you have to multiply 2 each and every element. So basically, in the case of matrix multiplication with a scalar value, you have to multiply k to each and every element. Can you see that? If you're writing here Ka, written over here Ka, what it means, you have to multiply k to each and every element, and that is called as Aij in the order m cross. In the order m cross, for it, you need to multiply the constant with each and every element. Okay. Again, the properties of scalar multiplication. Let's have a look. So lambda times a plus b is same as lambda a plus lambda b. Means I can distribute the lambda as a scalar over addition a and b. Same over here, if you have negative lambda multiplied with a, I can take lambda multiplication with a first and then include the minus sign, or I can multiply, this in this way as well. Anyways, okay. Property number 2, if you have two scalars, lambda plus mu, you can add or multiply, or you can multiply and then add, result is same. If you even have this in product, remains same only. Okay, lambda mu or mu lambda does not matter. So we have a question over here to solve. Let's look at this. Given matrix A and B is there, we need to find the sum of A and B. What we do better over here in the matrix A and B, you add the respective element, respective corresponding, right? First check the order is same or not. Yes sir, order is 2 cross 3. Here also it's 2 cross 3. Now add them. Root 2 plus root 5. What is the element going to be? Root 2 plus 5. Minus 3 plus root 7. That will become minus 3 plus root 7. 4 minus 2. That will be 2. 1 plus 3. That's 4. Minus 5 plus 1. That's minus 4. And 2 plus that. This is 1.5, right? This value is 1.5. This becomes 3.5 or 7 by 2. You can write that as 7 by 2 also. Your choice. So you add the corresponding element. Now this time you multiply a scalar to the matrix A and then you subtract. So again, to subtract, we need to check the order is same or not. So also is the question. Okay. So order is, sir, 2 cross 3 here also. 2 cross 3. Yes, that means we can subtract. Let's find 2A first. What did I say about 2A? Multiplying a scalar to a matrix, you got to multiply to each and every one element. Okay, so 2 into 2, that's 4. 2 into minus 1, that's going to be minus 2. 2 into 4 is 8, and 2 into 5 is 10. And then we have 2 into 0, 6. That's my 2A, right? Yeah, 10, 0 and 6. We need to find B, already we have, so we'll find this value directly now. 2A minus B. Subtract the corresponding element, so 4 minus 1, that's 3. Minus 2 minus 3, that's minus 5. 8 plus 2, that's 10. 10 minus 4, that's 6. This is 5, and 6 minus 6 is 0. Clear? Right? Okay. So yeah, these are simple questions, but these are the basically what we are doing right now. No, whatever concept we are learning, we are trying to solve question on that so that we can relate that the problem solving to the concept side. Okay. So I know this is easy, but we'll follow the same pattern in all the questions, all the topics that are gonna come. In all the one-shot lecture, Make sure that you are able to use the concepts in question solving of boards as well as CET. One shot has only one role over here, that you need to be able to use the concept in problem solving of both type of questions. Find the value of x and y from the following equation. Okay, so we'll have to form the equations, right? X is here and y is here. Let's try with x now. 3x plus 3 into 4, that's going to be 12. Scalar multiplication, 3x and 12, and sorry, we don't need 12, right? Do we? We don't need that. We'll have 3x over here, we'll have 2 over here, so 3x plus 2 is equals to the first term. We'll do a scalar multiplication alongside comparison as well, right? So scalar multiplication, sum of two matrices and the comparison. When you do that, 3x plus 2 equals to 14, we get 3x equals to what? Equals this side 12. That means x is 4 and x is what? Let's look at this. 3 into y minus 2, that's as it is 3y minus 2, and we get plus 5 equals to this over here, this value 20. Bring on this side, we'll get 3y minus 2 as 15. 3 will cancel this 15 by 5. Let's continue. Y minus 2 is 5, which means y is going to be 7. Y will be 7. Okay, x is coming as 4 and y is coming as 7. That's how you solve this question, which is given in the form of equation of matrices. Any doubt you are having, please let me know that in the comment section. Okay, yes, and for more practice, please join the channel's AIO page and get the access. Next question. Over here we have, if a matrix A is given as such and B, we need to find AB and BN so that AB is not equal to BA. Remember in the multiplication property that we were looking at, okay, so we'll see this later. Let me do this question later actually. This property, no, we'll look at right now. This question will come back to it. Okay, let's come back to this question later. This we can solve. This is based upon scalar property only. The previous one is based upon multiplication of two matrices property. So we'll not look at that right now. I'll come back to it. Find the matrices A and B such that 2A plus 2B is given, A minus 2B is given. This is my equation 1. First of all, to do that, we need to make sure order is same. Is the order same? 2 cross 3, 2 cross 3. So order is same. Add them. Add 1 and 2. Why that, sir? Because we have plus 2B minus 2B. We'll get 2A plus A as 3A. Now this will become 0. 2B and minus 2 will become 0. Now add the elements. 1 plus 3, 4. Minus 2 plus 0, minus 2. 3 plus 1, back to 4. 2 plus minus 1, that's 1. 0 plus 6, minus 1 plus 2, is what we have. Means my value of the matrix A coming as 4 by 3, minus 2 by 3, 4 by 3, 1 by 3, 2 and 1 by 3. This is the matrix A value. How define matrix B? So I need to find the value of matrix B. I can take from here or there any place. Okay, let's do that. We get here matrix A minus 2B is equals to that particular value. 3, 0, 1, minus 1, 6 and 2. Let's bring this over here and this over here. We get A minus this particular matrix equals to 2B. What is A going to be? Let's try that. This is over here. Okay, so we can do that over there only. Let's do it over here. If I have to find out A minus this, let's call this to be matrix X actually. Let's call this to be matrix X. Okay, we'll do A minus X over here as check here. 4 by 3 minus 3. That becomes how much? Is the negative value minus 5 by 3. Correct now? 4 by 3 minus 3 will be what? 4 by minus 9 by 3. That becomes minus 5 by 3. That's my first element. Minus 2 by 3 minus 0. That's simple. Minus 2 by 3. 4 by 3 minus 1. That is 1 by 3. 1 minus minus 1. That becomes 2. This is 2 minus 6. That's minus 4, and 1 by 3 minus 2, that's minus, okay, that's minus 5 by 3 actually, minus 5 by, correct. 1 by 3 minus 2 is how much? 1 by 3 minus, how much is it? 6 by 3, that becomes minus 5 by 3. This is my A minus X. If I call this to be matrix X, I want to find the matrix B. So B will become what? Difference by 2. So we'll write here, divide everything by this number 2, and that becomes minus 5 by 6 minus 2 by 3. So basically let's write it as 6 only right now. 1 by 6 over here, 1 over here, minus 2. This will become minus 5 by 6. Okay. If you want to simplify this as minus 2 by 3 also. So let me just do that. Sorry, minus 1 by 3. That will become. So this is your final answer for the matrix B and for the matrix A. Please cross check. Have a look. I hope this makes sense to all of you. Yes, clear, no doubts. If you have a different answer than what I've given for matrix A or B, let me know that in the comment section. Okay. If you want to look for a little bit. Yeah, moving on. Now, again, we have a matrix A and scalar multiplication. Then find the value of KAB. We'll have to look for combination of constants and variable together so that we can find first any of the missing variable and then look forward from there. So if I multiply K with the matrix A, let's say, if I do K with the matrix A, do it, 0 into K is 0, 2K, because as I said, you have to multiply K to each and every element. So 3K and minus 4K. Now K is given over here, so compare it please. This is 0, 3A, 2B and 24. Now if you check, if I compare element 3K, 2B, 2K, 3A, you have two variables. But if you compare these two, yeah, you will have only one variable, which is K. That gives me 6, K value as minus 6. If you're not sure, please do your own calculation, but K value is coming as minus 6. Once you have the K value, we'll put back over here. We'll get 3K is equals to what? This element is equal to this element, 2B. So 3 times of minus 6 is equals to B. I'll bring this 2 over here. That's again 3. My B value is minus 9. B value is minus. Same will do for this also. 2K as 3A. So right here, 2K equals 3A. Right? So 2 times of minus 6 equals 3 times of A. We'll move it over here. We'll end up with minus 4. We'll end up with minus 4 as A. My value for, they're asking us in the order KAB. They're asking us in the order KAB. So K is minus 6, A is minus 4 and B is minus 9. So minus 6, minus 4, minus 9. Minus 6, minus 4, minus 9. That's my option B. They're asking us in the order KAB. We'll write the answer also in the same order, minus 6, minus 4 and minus 9. Okay. This is a KCET style question if it comes from this concept. Now this is a board question. Okay. Board style can be asked in MCQs also, but can be asked in CET as well. You will not believe it, many of the questions of board style is present in CET also, because the chapter itself is very easy. And in CET, the syllabus is strictly aligned to NCERT. Some of the questions are very much similar over here. Now, we'll start from here again. Multiply this. We'll multiply cos with all the elements. We get here cos square theta. Cos into sine will be simply cos theta sine theta minus cos theta sine theta. This is again cos square. This is the first part. This time we're going to multiply sine to all the elements. Sine square theta minus sine theta cos theta over here. Sine theta cos theta over here. Sine square theta. If you add them, I think all of you know the answers. Obviously, sir, cos square plus sin square will be 1, sir. Cos sin minus sin cos. 0, sir. Minus cos sin plus sin cos. 0, sir. Cos square plus sin square. Again, the answer is identity matrix of the order 2. So, I0 and 0, 1. Sometimes they can also give you I or I2. It's the same thing. This means as matrix I, or sometimes this as I2 or 2 cross 2. Doesn't matter. I hope it makes sense. Okay, sir. All right. So this is also a CET style question. Okay. If 1 omega omega square are cube roots of unity, they're all cube roots of unity, then find the value of a square plus b square. Find the value of a square plus b square. We'll do that. We'll start. What is the property of this? 1 plus omega square is equals to what? 0. If 1 omega square are the roots of what? Unity means x minus x cube minus 1, this cubic polynomial, then sum of the roots will be 0 over here. That's the property. Okay. So let's try what we can get. We can make the relation from here. First of all, we are getting the relation. We compare this element 1 omega a and 0. What we are getting, beta? 1 plus omega plus a, right? 1 plus omega plus a is equals to 0. Basically 1 plus omega is equals to minus a. This is clear. Same way, let's do for b also. B you will find over here. This is simple. This is simple, right? So you will get over here comparison as minus b plus 2 is equals to 1. Minus b plus 2 is equals to 1. So from here you get what? Check this out. You get this value as b is equals to, because you're moving b over there, 2 minus 1. So b is equals to 1, sir. B is equals to 1. Okay. Now I want to find the value of 1 plus a square plus b square. A square plus b square. So you can take over here minus a square also plus b square. What is the value of minus a square? Check here. 1 plus omega and plus b square. Take the square of this. You will get here 1 omega square plus 2 omega, right? That's the expansion of 1 plus omega the square, a square b square, 2 into a into b, and b value is 1, so it becomes also 1. Check here, 1 plus omega square, separate it, okay? Write omega plus omega, omega plus omega, and this 1 as it is. Check, this value is nothing but 0. We're getting 0 plus omega plus 1. That gives me as 1 plus omega, and that is my value of what? This is the value of a square plus b square, right? My answer is what? 1 plus omega. That is option number. Good question, right? All of you liked it? Yes. Anybody had doubt in this question? Let me know in the comment section. I'll clear it up. I'll help you out. Okay. Just understand this. The property starts from, since 1 omega and omega square is cube root of unity, right? What it means is, it means for this equation x cube minus 1 equal to 0. It's a cubic function, right? They'll have 3 roots, and the roots are what? What are the roots? 1 omega and omega square, okay? Then sum of the roots will become what? Sum of the roots as alpha plus beta plus gamma, the concept is there. Take over here, that is result minus b by a. There is no x square term, that's why it will become 0. This is the property, okay? From there everything is simple. Let's move on. Let's move on to the property of multiplication of matrices. Multiplication of matrices. How does it work? Now, matrix is a basically arrangement of data either in rectangular or square matrix form, right? In which the order is what? Always number of row equal to number of column. So whatever it is, if we are multiplying two matrices, it will have different condition than we usually have in numbers. Of course, sir, right? There's a different rule also. Okay, there's a condition for order, the condition for always, this is well. There's two important conditions to multiply any two given matrix A and B. Of course, if you have matrix A and B, you write the product as AB. But when will this exist? I'll tell you. So if the order of matrix A is, let's say, m cross n, and order of matrix B is, let's say, n cross P, then only we can multiply any two given matrix. That's the first thing. If you have this value and this value equal, then only matrix multiplication is defined for the given two matrix or possible for the given two matrix. In other cases, sir, not possible. Just understand, number of column in the first matrix, should be equal to number of rows in the second matrix, right? If the order of A is m cross n, n represents number of column in the matrix A and n represents number of row in the matrix B, number of column of A should be equal to number of row of B. If you don't have this, then matrix multiplication of the given two matrix AB is not defined. As simple as that. Clear? This is clear? Okay. Now once it is defined, the resulting matrix is going to be matrix AB, and for that order will be M from here and P from here. It will become M cross P. That will become M cross. Now this is very important. The resulting matrix after multiplication is going to be always or number of row from here, number of column from there, M cross P. So these two combines and these two should be equal. Clear or not? Right? Now, whenever you multiply a matrix, you always multiply from row to column. So row of the matrix A you're gonna take and multiply to column of the matrix B, and that'll give you your one element. Okay, that'll give you your one element. Now, square matrix A is said to be idempotent matrix if A square is equals to, if the square of matrix means multiplication of A to itself is equal to A, that is called as idempotent matrix. Okay, that's the condition of idempotent matrix. Clear, sir? No doubt over here. Now, what is the meaning of this? Let's say if you have 1 2 3 0 and you have over here 6 1. Check here. 2 cross 2 is the order here and 2 cross 1 is the order here. You know very well that, sir, this will become, resulting matrix will be order 2 and 1. 2 and 1. And how do we multiply? Row here and column here. That will give me one element. So 1 into 6 and 1 into 1, 2 into 1. We'll have 1 into 6 plus 2 into 1, that is going to be simply 2, and 3 into 6 is 18, and 0 into 1 is 0. The answer is what? 8, 18. 8 and 18. 8 and 18. This is how you do multiplication of two matrices. Here some more examples, have a look. After this we'll solve that question that we had. Okay, let's do the properties first, then we'll solve. Here the properties here, right? Let's do this part first, then we'll solve that. Okay. Looking at question that I want to solve over here. Moving on. So we have an example given to us. Matrix A is here. What is the order over here of matrix A? 1 into 3. 1 row, 3 column. What about B? 3 row, 1 column. Right? Row matrix, column matrix. Multiply here. How do you multiply? Row to column. So 1 into 5, that's 15. That's 1 into 5 is 5. 3 into minus 4 is minus 12. And minus 4 into minus 2 is plus 8. So you get here 5 minus 12 and plus 8, that is going to be only one element, which is 1. That's only one element which is 1. Okay, this is how you get the element. Anyway, check it out. If your matrix order was 1 cross 3 and B was 3 cross 1, this is equal. And so resulting will be what? Matrix AB, and the order will be what? 1 cross 1. Means one row, one column. That's your answer over here. That is your answer over there. Okay, sir. So here BA also defined, because again same thing is working in our favor. Let's try doing BA also. Let's try doing BA for ourselves. Let's write BA. Matrix BA will find. Why can we do BA, sir? We can do it because matrix B is, sir, order 3 cross 1, and matrix A is, sir, 1 cross 3. Again you check, these two are equal. That two are equal. And for BA what will happen? For BA you will have a order 3 cross 3. How will it work? Let's check. Let's write B first. B will be over here, 5 minus 4 and minus 2, and let's write A over here, 1, 3 and minus 4. What did I mention? Row to column. So 5 into 1. One row, one column gives you one element. 5 into 1 is 5. 5 into 3, that's first row, second column, that's 15. 5 into minus 4, that's how much? Minus 20. I hope you are clear. One row with one column gives you one element. Now try with second row. Minus 4 into 1, that's minus 4. Minus 4 into 3, minus 12. Minus 4 into minus 4, that's 16. Minus 2 into 1 is minus 2, minus 6 and plus 8. This is the case of AB when the element is 1, and BA it's a 3 cross 3 order square matrix. I hope this is clear. Please check. Because most of the questions, whether it is boards or CET, comes from matrix multiplication only. Okay. The properties are there. First one is commutative property. This is not true for the case of matrix multiplication. So AB is not generally equal to BA. This is actually equal, but only when AB is equal to BA and the product is equal to identity matrix. So only when A and B, you learn it in determinant, are inverse of each other, only AB and BA are equal, and that is equal to identity matrix of the same order, of course. Okay. So generally, matrix multiplication is not commutative. Not commutative. Moving on. That's property number 1. Property number 2. Yeah. Matrix multiplication is associative. They have asked this question multiple times in your boards. To prove it, they'll give you a 3 matrix ABC. They'll give you 3 different matrix ABC, and they'll ask you to verify, to check in this way. You have to multiply AB first, then C to it, and or otherwise you have to multiply BC first and then A to it. You'll get same matrix. This is called as associative law of matrix multiplication. Associative law of matrix multiplication. Next, this is called as distributive law, right? You're going to distribute multiplication over addition. Even this is one of the favorite questions for second PUC board, and they ask it for 5 marks. Okay, I have brought a question to show you how they ask, but yeah, they ask you to distribute A over the product of A over sum of B and C. So it becomes AB plus AC. You can distribute C also over A and B, AC plus BC. I hope this is clear. These are the 3 major properties of multiplication. Okay. Property number 4. The product of 2 matrices can be a null matrix even though they are non-zero. Means a matrix A is not a null matrix. Matrix B is also not a null matrix, but still AB can be equal to 0. How come, sir? Yeah, because when you do a multiplication of 2 matrices, what happens? You end up adding, and multiplying individual element, right? So sometimes the sum can become 0. Sometimes the product can come as 0. Okay, that's why AB can be 0, even though A and B are non-zero matrix. This is again for identity matrix. If you can multiply with I, you get result as back to itself, and if you multiply with null matrix, You get the answer as null matrix only. So A into 0 is 0, A into I is A. Sorry. And both of them are important. Now, on this concept, there has been a question on in KCET, which is called as positive integral powers of square matrix. Okay. So, in any of these questions, right, basically the conditions of index will apply. Indices is there, right, when matrix is basically A square is A into A cube is A square into A, like that, that is going to apply. But the point over here is that if you have a question which is asking A power 6 or A power 10 or A power n, any type of question they're asking, just try to find A square, okay, and from here you can find out all these values. See, you can write A as A, you can write A square as A into A, you can write A cube as A square into A. Just find the A square, and from there you can find any of the conditions without actually doing the multiplication of matrices. So better, multiplying a matrix is a very difficult thing, right? It will take time. It's a time consuming thing. It's not difficult, it's a time consuming, and chances there you can make mistake. That we're gonna be, that's gonna be increased if you multiply two matrices. So if you are supposed to find A power 6, A power 10, A power n, rather of finding that, you can simply find A power 3 as A square into A power 4 as A square into A square, A power 5 as, what is it going to be? A square into A square into A. I'm not doing multiplication. You can put the values of A square and still simplify. Getting it? I hope you're getting it, right? So there's a CET question on this, which is very good, and we can solve it just by doing A square. So any question of positive integral power of square matrix can be solved using what? A square, and should be solved using what? A square only. I hope it makes sense to all of you. Okay, moving on. Acha, the order of single matrix obtained from the entire process is what? Check multiplication, right? So first of all, inside they are same, 2 cross 3, 2 cross 3. Difference will still be 2 cross 3 only. What is outside? Check here, 3 cross 2. What is it? 3. This is multiplication, right? 3 cross 2. 3 rows, 2 columns. They are equal. Answer will be what? 3 cross 3. 3 cross 3. That's option. Clear, right? Is it clear? Okay, let's move on. The next question. A is given as 2 cross 2 matrix alpha 0 1 1. B is given as 1 0 5 1. Then find the value of alpha for which A square is B. A square is B. This is that integral power wala question. Let's find A square first. How do you find A square beta? Just simply alpha 0 1 1, alpha 0 1 1. Let's try row to column. Okay, so we have alpha square. Okay, acha, do one thing. We need to find the value of alpha, right? And this is the MCQ. Correct, na? Yes or no? We need to find alpha value, and this is the MCQ. It means we just have to understand the condition that create a variable form in the A square matrix and compare it with the matrix B, and just compare those elements. So what are you saying? Just wait a second. Alpha into alpha, how much is that? Alpha square. 0 into 1 is how much? 0, sir. Alpha square plus 0. What about other terms, sir? Do we need it? Actually, do we actually need it? Please check. This should be equal to what? Matrix B. And what is matrix B? 1 0 5 1. So we don't need to do the entire multiplication since it is MCQ. So just check this out. Alpha equals to alpha square equals to 1. But alpha is what? Plus minus 1. Achha, one more thing is there. Now in this case, usually this works, but in this question it does not work. How come, sir? Because you have an option which is saying no real values, and you are getting two answers for this. It means alpha can be 1 also or minus 1 also. Now think about it. In a question which is a MCQ single correct choice, can you take option A and B both? No. Unless you have given the option, third option as or fourth option as all of the above, or option A and B both. So usually the answer will come as option D. But since we have to be sure, right? So let's multiply. This is 0. Let's multiply this with 0 and 0. That is gone. And then we multiply this with, okay. And if you multiply this with we get alpha plus 1. From here I'm getting alpha plus 1, this term. Alpha plus 1, that is equals to 5. So compare it again, alpha is equals to 4. So I'm getting 3 values actually, 1, minus 1 and 4 also. Now, in this particular matrix, I cannot have contradiction, right? I cannot have contradiction. It means answer is what? No real value. Good question. But usually, please understand, if you're looking to find any missing variable, you won't have to find entire multiplication, just or entire finding inverse or anything. Just try to look for the option whichever is most suitable one and do the minimal operation, okay, to get the result. Acha, I forgot we had a question to solve. Remember that property wala question? Where is it? A, B, B, A. Here it is. Right? Let's solve this one. Remember, we just learned right now, matrix multiplication is not always commutative. This is the same result. Correct, right? AB is not equal to BA. We have to find AB first. Let's check if it's possible to find AB. So it is 2 cross 3 and this is 3 cross 2. It's possible. Let's find AB then. Achha, AB is not equal to BA. We can find, if it was the MCQ, we can simply check using order also. Check. AB is going to be what? AB will be, sir. AB will be, sir. Have a look. So AB beta will be, over here the order is 2 cross 3, here the order is 3 cross 2. So for AB you will have what? Order as 2 cross 2. What about BA, sir? For BA, the order will be what? B order is 2 cross 3 and this is 3 cross 2. Multiply. What is the 1 second. 2 cross 3. So this is wrong, right? B is 3 cross 2 actually. 3 cross 2 and A is 2 cross 3. You'll have the answer as BA equals to 3 cross 3. Now you tell me, is it possible to get a 2 cross 2 matrix equal to 3 cross 3 matrix? No, not possible, sir. It means clearly this is wrong. But we have to show it. This is a subjective question, so we have to find ABBA. If it was an MCQ, just by using order, we'll get our result and move on. But this is a subjective question, we have to find that. Let's find that. Okay. Let's find AB then. Okay. We'll multiply row to column. For the first element, 2 minus 8 and plus 6. 1 into 2 is 2. This is minus 8. So we'll write this. This is what, sir? Plus 6. Next one. 3 minus 10 plus 3. We have 3 plus minus 10, 3 minus 10 and plus 3 again. Over here you check. Next second element, second row, sorry. The second row value, yeah. Now for the second row, check here. Minus 8 plus 8, so cancelled. Minus 8 plus 8 cancel, plus 10. Minus 12 plus 10. Minus 12 plus 10 is how much? Minus 2. And then plus 5. So minus 7. Plus 5 means plus 3. Correct, na? Minus 12 plus 10 is minus 2 and plus 5 is 3. The answer for AB is coming as beta what? This is the 6 plus 2 is 8, so this is 0. This is the 3 plus 3 is 6 minus 10 is minus 4. This is 10. This is 3. That's your matrix AB. What about BA, sir? What about BA? Again, we'll go from this time we'll go from where to where? From here. 1 second, check. B to this. Okay. 2 into, we'll do row to column. So 2 into 1 is 2 and minus 12. 2 and minus 12. That is how much? Minus 10. Next, this with this. So minus 4 plus 6. Minus 4 plus 6. How much is that? Minus 4 plus 6 is 2. Then again we go 2 3 is 6 and 3 5 is 15. So 21. Check calculation please. 2 3 is 6 and 3 5 is 15. Correct. Next row we're gonna start. 4 into 1 is 4. 5 into minus 4 is 20. So minus 16. 4 minus 20 is minus 16. Minus 8 plus 10 is 2. Minus 8 here plus 10 here. Next. 12 and 25. 12 and 25, that's 37. Next, last one. 2 and minus 4, that's minus 2. 2 into 1, 1 into minus 4, that's minus 2. minus 4 plus 2, that's minus 2 again. Minus 4 and plus 2 is minus 2 again. 6 and 5, that's 11. 6 and 5, that's 11. So can this be equal? Please check. Clearly, AB is not equal to BA. This is for the subjective question, but usually in the case of objective, understand this, the order will not be different. So 3 ways to solve this question. The property, if it is AB is not equal to BA, the commutative property of multiplication of matrices, order will be different. So that's why it is not equal. And either you can solve it also and not equal. Clear? Clear, sir? Yes, sir, clear. Now we'll move on. Okay. Another question. This is that 5 marker I was talking about. This is the 5 marker question. A is given, B is given, C is given. Calculate AC, BC and A plus B times of C. AC, BC and A plus B times of C. Let's do AC first. You calculate this, no? Multiply this. Multiplication should be careful, okay? Let's try this. So this is the 3 cross 3 matrix, both of these. The 3 cross 1 matrix. The result of this will be what? A 3 cross 1 matrix. 1 into 3 is 3, 4 into minus 3, minus 1 is minus 4 and then plus 4. Sorry. 3 minus 4 and minus 4. So 3 minus 8, that's minus 5. Correct? Am I right or not? Please check. Calculation, I need to be careful. 1 into 3 is 3. 4 into minus 1 is minus 4. Minus 2 into 2 is again minus 4. Minus 4 and minus 4 is minus 8. And plus 3 is minus 5. Next. Second row. 9, 0 and 10. 90. 9, 0 and 10. 90. Minus 3, minus 2 and 12. Minus 3 from here. Minus 2 from there becomes minus 5. And then becomes 2 times of 6. 12. So 7. 12 minus 5 is 7. This is my AC value. Let's look for, what is it? BC now. Let's look for BC now. Same. Start from here. 6, 1 and 6. So 13. 6, 1 and 6 is 13. 6, 1 and 6. That's 13. Again. 0, minus 4 plus 2. That's minus 2. Minus 4 and plus 2. That's minus 2. 15. Minus 2 and minus 4. 15 minus 2 and minus 4. Minus 6, that becomes 9. Please check. 5 is a 15, minus 2 and minus 4. That's minus 6. 15 minus 6 is plus 9. Correct. That's AC and BC. Let's add them. We found AC and BC. Let's add them because we need to find AC plus BC also. If we add them, we'll end up with what? AC plus BC, and my answer will come as 8. Okay, correct now? Right? If you add these two, what are you gonna get? Minus 5 plus 13 is 8. 19 will become what? 17. 7 plus 9 is 16. This is AC plus BC. Let's try A plus B now. I might have made a mistake in calculation, so let me know in the comment section, okay, if I made any mistake, any numbers is wrong. A plus B. But we'll check. Anyway, we'll be able to verify that. So 1 plus 2 is 3, minus 3, 1, right? 4 minus 1 is 3, and this is going to be plus 1, correct? 1 plus 2 is 3, 4 minus 1 is 3, minus 2 plus 3 is 1, 3 plus 0 is 3, 0 plus 4 is 4, 5 plus 1 is 6, minus 1 plus 5 is again 4, 2 plus 2 is 4, 6 minus 2 is again 4. And we multiply this with C now. So A plus B times of C. Okay, we'll multiply again. Let's try this here itself. Multiply this with C. C is how much? 3 minus 1 and 2. Let's check this out. 9 minus 9, 9 minus 3, that is 6 plus 2, 8. 9 minus 4 and 12. So 9 plus 8, 17. 9 and 4 minus 4 plus 12 is what? Plus 8. 12 minus 4, that's 8, and 8, 16. So 8, 17, 16. Yeah, correct. You can see. So there's no mistake in the calculation. Okay. So we have, this is basically what is it? Proof of distributive property over multiplication over addition of matrix multiplication. Right? Correct, no? This comes for 5 marks in the boards. And the chances of this appearing in your even midterms is also high. Okay, this is a good question. A transpose of a matrix. Matrix obtained from a given matrix A by interchanging its rows and columns is called as transpose. Basically what it means, if I have a matrix over here and let's say 2, 3, 5, 7, 8, 9 and you want to write this as transpose, so what happens, no, this row becomes column. You have over here 2, 3, 5 and this will be 7, 8, 9. This was a 2 cross 3 order matrix and this will become 3 cross 2 order matrix. When you take transpose, the row and column interchanges and the order also becomes just opposite. 2 cross 3 becomes 3 cross 2. That's how the transpose works. Okay. Thus, if A equals to, if I have, so basically the same thing is there. Can you see that? Aij is coming to this as Aji and this was M cross N becomes N cross M. The order is changed, so is the element also. Ij becomes Ji. If it was, what is this element? Here, A11. So this is also A11. What was this element, sir? This element was A12. What is this element, sir? Second row, first column. So A12 is 3, here A21 is 3. That's why Ij becomes Ji. Aij becomes Ji. Check here. A13 is 5, first row, third column. A31, third row, first column. Okay. This is first row, third column, 5. This is third row, first column. So A31 is 5. Okay, example is also given over here. Okay. Now, Acha, one more thing before I go into this. In the case of a square matrix, of course, order will not change, right? Because this is going to be always n cross n. Even if I reverse it, this will be what? N cross n only. It will not change. Will it? It will not change. So, what happens in this case? I'll show you. And this is my diagonal of a 3 cross 3 order matrix. And we have -4, 8, 0. And we have 2, 1, 6. 2, 1, 6. If I call this to be my matrix, let's say A, then matrix A transpose will be what? The diagonal will remain same. Of course, you can do the same what you did. Row to column. But actually what we do, we take the image about the diagonal. So over here, this over here. 2 over here, -4 over here. Same. 8 comes, 1 goes. So 1 over here, 8 over here. 0 comes, 6 goes. So 0 over here, 6 over here. So basically we reflect the elements in the diagonal. But if you look at the same logic, 5 minus 4, 8 in the row. Check here, 5 minus 4, 8 in the column. So the transpose condition is same. Row becomes column, column becomes row. But in the case of square matrix, this is also observed that it becomes reflective or reflected about the diagonal. Diagonal remains as it is. Check, -4, 7, 6. -4, 7, 6. This was the column. This is the second row. Third column, 8, 0, 8. Third row, 8, 0, 8. So the row and column will interchange. Okay, that we do. But actually, in this case, we can also take reflection about the diagonal as well. Got it? Clear? Okay. Properties of transpose of a matrix. Let A and B be suitable matrices. Then, if you distribute the transpose over sum, A plus B, sum of two matrices, it simply goes A transpose plus B transpose. If you distribute in the property number 2, if A is the matrix, if you take transpose on transpose, basically transpose the matrix A and take one more time transpose, you get back to the same matrix. Excuse me. And property number 3, if K is any number which is real or complex and you apply transpose on that, means if K is a real number or complex number, whatever it is, take transpose of K. K is the number, a constant will come out. You have a Ka dash. So Ka transpose, nothing but K outside A transpose. Okay, and these are important properties, bacha. It's not, please do not ignore these properties. Okay, very very important. The way you learnt about sum of the two matrices in transpose, same way it works in difference also. And if you have not seen your PYQ, let me tell you one thing honestly, this question have been asked in your KCET. One second. Excuse me. This exact question, how did they did? So they asked you actually A minus, I'll tell you how. I'll take the next page. Yeah, check here. They asked this, A minus B transpose is equal to B transpose minus A transpose. Is it true or false? This is right or wrong? They give one of the options. Choose the incorrect option. This is a false statement. This is a false statement because actually the true statement is what? A dash minus B dash. This is true. This is false. So the difference, even if you take, it acts same as the sum. Negative of A transpose is same as negative A transpose. Sign does not matter in the element of the sign of the element does not matter in the transpose. You can take it outside. Property 4. A and B are, this is the reversal law. This is called as reversal law. This is also very very important. So what happens in this? Let me show you over here again. So beta, if you have two matrix multiplied and you want to take transpose on that, the answer will be reversed. So you will take B first and then you will take A next. It becomes B transpose A transpose. What if you have three matrix? AB transpose, sorry, ABC transpose. The rule will still be same. You will take C over here, A over here, and B remains as it is. So you will take C transpose, B transpose, and A transpose. This two rule is called as reversal law. Reversal law. Have a look. Reversal law. Clear, right? I hope this is clear. Reversal law of transpose. ABC, C dash B dash A dash, and the AB is B dash A dash. Yeah. Actually, you can write transpose as either C dash or C transpose CT, same thing, right? Now, a very important concept, a favorite concept of your boards and CET, both equally important. Symmetric, and this is Q symmetric matrix. Q symmetric matrix. What's the meaning of this? What's the meaning of this? Symmetric matrix means if you take transpose of a matrix, you take transpose of the matrix and it comes same. It comes same. It comes same. If you take transpose of this matrix and it comes minus of the original matrix, then what happens is, then the matrix A over here is called as symmetric matrix, and over here the matrix A will be called as skew symmetric matrix. Means basically by taking transpose in the matrix A, if I get the matrix back to itself, it is called as symmetric matrix. It's called as symmetric matrix, and both these properties are true for what? Square matrices. This is true for square matrices, because symmetry will not hold true for rectangular matrix, isn't it? Symmetric will not hold true for rectangular matrix, right? Correct. Yes. Okay. A is a symmetric matrix, A is a symmetric matrix. Clear, guys? Clear, sir? Clear, sir? One more thing is a very important property. I would like to write it over here only. I can teach you in determinants also. I'll teach that as well. Determinant of a skew symmetric matrix of odd order. Odd order is always 0. Understand this. Okay, understand this. One more thing. In skew symmetric matrix, you'll find diagonal element equal to 0. You find that always 0. Okay. And if I were to give an example of this, let's say we have 0, 0, this is 2, then this will be minus 2. Example I've given over here. Over here, this is, let's say, whatever it is, 7, 4, and this is 2, it will be 2. You see that symmetry, right? If I try to transpose, take transpose of this, take transpose of this. That this has 7, 2, this 7 will come over here, 2, and this will be again same thing, 2, 4. Isn't this the same thing? And these two same. So equal to A transpose. Okay. Over here, if you go A transpose, you're gonna get what? This will go over here, and so will become minus. Okay. So this is clear. Achha, both of these are true for only square matrices. Let's solve a question on this. Not this one. Like let's solve a question on integral powers of A. We'll solve questions on symmetric also. Don't worry. Let's do this. I'm looking to find what? A power 16. What did I say? Always find A square that's sufficient to solve any question. 0, 0, x 0, 0, 0, x 0. Multiply 0, 0, this is 0, 0, 0, also 0, 0 is going to be 0, also 0, 0 and 0, coming as a null matrix. So A square is null matrix, means A power anything will be. You keep continuing. A power 16 is what? A square and power 8. 0 power 8 is what? 0 only. Answer is what? Option D. Answer is option D. Please have a look. Okay. Clear. Next, another question. This is on the transpose property. We have to prove the transpose property using this two matrices. So we'll start from the first one. Let's find A plus B first. Let's do it. We'll get 2 plus 1, which is 3. 2, 2, minus 1, 2 plus 5 is 7, 5 plus 7 is 12. This is 3, this is again minus 2, that's 5. That's 5. Let's take transpose of this then. What did I tell you? In a square matrix, you can take transpose like this. So keep this as it is, 3, 7 and 5, and mirror image. 2 comes here, minus 1 goes over there. This 3 goes here, 2 comes here. 12 comes here, minus 2 goes over here. This is A plus B transpose. Let's find A transpose now, guys. A transpose will be what? Over here. 2, 5 and 6 as it is. Another element, mirror image. Minus 1, 3, 0, 4, 7, minus 2. Let's find B transpose also. Let's find B transpose also. And in the case of B transpose, we'll have 1, 2, minus 1, 3 here, minus 4 here, 3 here, minus 2 here, 0 and 5. Now add them. Let's do it. Let's add it. A transpose plus B transpose. We'll get what? Check. 2 plus 1 is 3. 3 minus 4 is minus 1. 0 plus 3 is 3. Minus 1 plus 3 is 2. 5 plus 2 is 7. Minus 2 plus 0 is minus 2. 4 plus minus 2 is 2. 7 plus 5 is 12. 6 plus 1 is 6 minus 1 is 5. Cross check, please. Cross check. 3 minus 1, 3. 2, 7 minus 2. 2, 12, 5. What we're getting? A plus B transpose is equals to what? First one is proven. Second one, please try. Please try this. Exact same. Take the difference of these two, and we already have this two value. Take subtraction over here also. You can do it, right? Correct now? You can do it. Okay. All right. Let's move on. Another question. Property. This is also a question which comes from 4 marks usually sometimes in your course paper. Okay. You need to verify AB dash and B dash A dash is same. Property of transpose. Okay. Let's do AB first. Multiply AB. Minus 2 into 1, which is minus 2. Minus 2. Minus 2 into 3, that's minus 6. Minus 2 into minus 6 is 12. 4 into 1 is 4. 4 into 3 is 12. Minus 24. 5, 15 and minus 30. That's AB. But now we're going to find what? AB dash. We'll find what? AB dash. What happens in this case? Minus 2, 12 and 30 as it is. Theta transpose, minus 6 comes here, 4 goes over there. 12, 5, minus 24 and 15. That's my AB dash. What is the next step? Finding B dash. The row will become a column matrix. So 1, 3 and minus 6 and A dash. The column will become a row matrix. So minus 2, 4 and 5. Let's do B dash, A dash. Minus 2, 4 and 5 as it is. Minus 6, 12 and 15. 18, sorry. 12, minus 24. And this is minus 30. Cross check now. Minus 2, 4, 5, minus 6, 12, 15, minus 12, minus 24 and 30. So this is going to be minus 30, right? This is minus 30, sorry. Check here, B dash A dash is coming as AB dash. So we have proven the property of transpose in product. Reversal law basically. This is the reversal law. Clear guys? Clear? Yes. Any square matrix can be expressed as a sum of a symmetric matrix and a skew symmetric matrix. This is a question that comes. This is the board's PYQ. Your second PUC board's PYQ. It comes. You need to prove it. Okay. So let's first prove. We'll do another proof over here, which goes like this. So we'll prove first whether this is symmetric or not. Let's try to prove that. Okay. Let's prove this is symmetric part or this is skew symmetric part. Okay, sir. How do you prove that? How do you prove A plus A dash is symmetric part? Think about it. You can take example also. Or otherwise, symmetric matrix means what? Symmetric matrix. Symmetric matrix means what? You have A dash equals to A. A dash equals to A, right? Correct. A plus A dash is equals to A is the symmetric matrix. Now, if I want to talk about this matrix first, let's take over here A plus A dash as a matrix, some matrix X. I can do that. Yes, sir, I can do that. In that case, beta, if I take same thing for X dash also, if I do same thing for X dash also, same thing for X dash also, what will happen? Please check. So one thing, I can write this as X dash actually. If X is a square matrix which is symmetric, I'll have X dash as X. Forgive me. For symmetric matrix, X dash is equal to X. Let's try. So if I take X dash, what happens over here? I'm going to take A plus A dash the dash. It becomes what? A plus A dash plus A dash dash. What happens over here? It becomes A dash plus A, which is same as A plus A dash. Check here, I'm getting X dash equals to A plus A dash, which is nothing but same as the matrix X. If I can prove that X dash is equals to matrix X, if X is a matrix, if I can prove this condition, it means what? It means X, which is this, is going to be what? A symmetric matrix. A symmetric matrix. Clear or not? If I can prove for matrix X, the matrix A plus A dash as X dash equals to X, it means it is a symmetric matrix. Same. Let's take Y equals to X minus X dash now. Sorry. Y equal to A minus A dash now. Now, for skew symmetric part, have a look. If I take Y dash, I should get what? Minus Y. Let's try that now. A minus A dash the dash. Now we'll take the transpose property. A dash minus A dash dash. It becomes A dash minus A. We can take minus sign common. It becomes A minus A dash. Check here, I'm getting Y dash equals to what? This is same as matrix Y, so minus Y. Whenever you have Y dash as minus Y, matrix Y dash as minus Y, it means Y is what? Skew symmetric matrix. Y is what? Skew symmetric matrix. So basically I have proved that over here A plus A dash is Q-symmetric matrix, and A minus A dash is Q-symmetric matrix, and A plus A dash is the symmetric matrix. Yes or no? So now if you look at this, if A plus A dash is symmetric matrix, then A plus A dash by 2 will also be a symmetric matrix. Same way, if A minus A dash is a Q-symmetric matrix, then A minus A dash by a constant 2 will also be a Q-symmetric matrix. By dividing with a number 2, a fixed constant, will not change the nature of the matrix, it will be still, because we are dividing every element by the same number 2, 2, 2. So if it is symmetric, this will also be symmetric. If this is Q-symmetric, this will also be Q-symmetric. This is to establish that this is the symmetric part, this is the Q-symmetric matrix. This much is established, sir. Okay. Now we have to verify from RHS whether this sum is coming equal to A or not. Let's try that. Let's try using RHS now. What is that? Half of A plus A dash plus half of A minus A dash. Take this out. LCM is same. So A plus A dash minus plus A minus A dash. Check here. A dash cancels. A plus A is 2A. Outside is also 2, cancels. I'm getting back to A, which is nothing but LHS. So we have done two things over here. First, proven that A plus A dash is symmetric, A minus A dash is Q-symmetric. This is the first part. Second part is showing that if A plus A dash is symmetric, then A plus A dash by 2 is also symmetric. If A minus A dash is Q-symmetric, then A minus A dash by 2 is also Q-symmetric. And then we showed that this sum is actually giving me back the matrix A. So yes, they are symmetric Q-symmetric part, and their sum is equal to the matrix A. It means I can express a matrix, any given square matrix, in the form of symmetric and Q-symmetric by writing in the form half of A plus A dash plus half of A minus A dash. I hope this is clear. I hope this is clear. Okay. Now this is from here onwards we'll solve the KCET PYQs. Let's solve KCET PYQs. Okay. Yes, sir. Let's do that. Now, cos alpha, sin alpha is given. I'm looking to find A into A dash. Let's find A dash first, bacha. So we'll have cos alpha as it is. Here also cos alpha as it is. This will come here, so it will be plus sin alpha. This will be minus sin alpha, right? Take product of A dash, A into A dash. Check. To multiply this cos alpha into cos alpha. How much is that, beta? Cos square alpha. Sin alpha into minus sin alpha. It becomes how much? Sorry. This sin alpha into this, because you're going to do column over here, right? So plus sin square alpha. Forget about this. How come? Tell you. Cos square plus sin square is how much? 1. Forget about the other elements. Why, sir? Look at the options. Option A, first element is what? Option A is matrix A. First element is cos alpha. What is the first element over here? 1. Not equal. So A is wrong. Option B is what? Zero matrix. Zero matrix first element is what? All element is 0, sir. So this is also wrong. A dash, third option is A dash. A dash, if you take, again, what is the first element? Cos alpha. That is also wrong. What is the fourth option? I. I means entity matrix. Your first element is 1, second is 0, again 0, 1. It means my option is D. Do not do over multiplication. Save time. It will help you a lot. Clear? Clear, right? Okay. Next. If P and Q are symmetric matrices of the same order. Okay, what it means? P dash is, P transpose is P, Q transpose is Q. Symmetric matrices. Then what is the value of, what is PQ minus QP? They are asking us, what is PQ minus QP? Now, let me ask you, product of two matrices is what? A matrix, sir. It means PQ is a matrix. Product of another two matrix, Q and P, also a matrix. Difference of two matrix is also a matrix. Then assume this to be the matrix X, na? PQ minus QP is also a matrix X. Take transpose. PQ minus QP the transpose. First we will apply the difference law. So PQ transpose minus QP transpose, right? And then we're going to apply the reversal law. PQ becomes Q dash P dash and QP becomes P dash Q dash. Q dash is how much? Q. P dash is P. I'm getting X transpose. Have a look. As take minus sign common, it will become PQ minus QP because we had QP minus PQ. I've taken minus common. X transpose is coming as minus of from here X. Whenever X transpose is minus X, it means X, which is nothing but PQ minus QP, is what? Q symmetric matrix. Is what? Q symmetric matrix. Answer is option. Answer is option. Clear, right? Previous one is clear, no? This is clear. Next, if you have 3a plus 4b dash, next question, again from CET PYQ only. Just to understand, okay, when we are learning this one shot, our goal is to be learn all the concepts, all the definition, all the properties, and let's check whether can we solve questions of boards and CET together or not. I have solved questions of boards also, I have solved questions of CET as well. It means whatever we have learned in the session is applicable and is good for our preparation. 3a plus 4b dash, 2b minus 3a dash. You can see clearly over here we have presence of 3a and minus 3a because to solve any equation I need to eliminate one variable, right? That can be matrix A over here. Just that I need to take transpose of something. Let's do one thing, take transpose of this. Take transpose of this. We'll have over here 2b dash minus 3a dash dash. Correct? When you take transpose, it becomes constant is as it is, b dash, c also as it is, transpose of transpose, so a dash dash. And what about this side, matrix part? It is 3 cross 2, it becomes 2 cross 3, minus 1, 4 and minus 5, 18, 0 and minus 7. This is a 2 cross 3 matrix. Let's write that now. We have over here 3a plus 4b dash equals to matrix that we have 7 minus 10 and 17, 0, 6 and 31. Now check. A dash dash is what? A dash dash is what, sir? Simply matrix A. Simply matrix A. Right? Matrix A. You add them, this 3a and this 3a will cancel, and you have over here what? 6b dash. You'll have over here 6b dash. Add them. Minus 1 plus 7 is 6. 4 and minus 10 becomes minus 6. And we have over here minus 5 plus 17, that's 12. Okay, if you want, you can get the answer from here only. Check. Divide by 6, you'll get what? 1, minus 1 and 2. This is for B transpose. In a row, I want to find the B. It means 1, minus 1 and 2 should come in vertical form. It means either option A or option D. Okay, let's try. Let's check the last element is what? Positive over here. That's why option is option A. Answer will become, see, minus 7 plus 31 is how much? 24. That's the positive value. So answer is what? Option A. I'll solve it entirely for you, don't worry. Add them. 18 plus 0, 18. 0 plus 6 is 6. And this is 24. Now divide by 6. So what is B dash going to be? We'll have the same value as 1, minus 1 and 2, 3, 1 and 4. And since it is B dash means B will become what? The column matrix, not column, 3 cross 2 matrix. It becomes 3, 1 and 4. I said the option is A. Let me check. They're asking us B, not B dash. We found the value of B. Clear, right? Want to look again? Check. Now we're looking to find the value of another KCET problem, A power 4. As I said, whatever is given, just find the A square first. 0, 0, 1, 0, 1, 0, 1, 0, 0. Check. 0, 0, 1, 0, 1, 0 and 1, 0, 0. Multiply 0, 0, 0. Excuse me. Sorry. This seems wrong. 0, 0 and 1. Sorry, this is 0 into 0, 0 into 0, 1 into 1. That's 1. 0, this is 0, this is also 0. 0, 0, 0. How I'm writing 0, 0, 0? Because either both are 0 or 1 is 0. Multiply them, it becomes 0. Only when it is both 1, then it becomes 1. 0, 0, 0. 0, 1, 0. 0, 0, 0. 0, 0, 0. 0, 0, 0. 1, 0, 0. So this is 1. This is coming as identity matrix. Option is B. Clear, right? Clear now? Have a look. Okay, this is the question. Another problem, CET problem again, CET P by Q. A and B are square matrices of the same order and B is a skew symmetric matrix. Then A dash B. Whenever you find this kind of, A plus B or PQ plus QP, whatever it is given, okay. If you find something like this, always write this A dash BA as the matrix X. Assume it like that. And apply the property transpose. X transpose will be A dash B A. Here we can use what? Reversal law. This A will come front, will become what? A dash. This will be B dash. Okay. And this will become, this will go here, right? So A dash dash. What I'm getting over here? What they've given, please check. A and B are square matrices of same order. And B is skew symmetric. They've given B is skew symmetric. It means what? B dash is minus B. We don't have any information about A. We don't know whether it is skew symmetric or symmetric for matrix A. But for matrix B, we know that it is skew symmetric, means A dash will remain A dash, B dash will become minus B. This will become what? Because A dash dash is A. I'm getting the answer as minus A dash BA. Check carefully. A dash BA is X. So it's coming as minus X. For what? X transpose. Answer is what? Option C, skew symmetric matrix. Option C, skew symmetric matrix. Makes sense, guys? Does it make sense? Okay. Now next is multiplying AB and finding the transpose. Very simple problem, right? Let's find AB then first. Or you can use the property also if you want to, B dash into A dash, but doesn't matter, not required. Let's go about this. 2 cross 3 and 3 cross 2. We'll have the answer as 2 cross 2. So 1 into 2 is 2. We'll have 2 minus 6 and 1. So 3 will have, correct now? So minus 6 is there. So minus 3 will have 2 minus 6 and 3. So check, every element has minus 3 in it. Every element has minus 3 in it. Okay. So now we'll check to find our, see, this is different. Minus 2 is different, 10 is different, 7 is different, and 7, this is also there. Okay. So let's try to find out second element and then take the transpose of that. Okay. We'll multiply this 1, 4, minus 4 and 1. That becomes minus 2. This is AB. So if you write the AB transpose, check here, you'll have minus 3 and minus 2. You don't know what is this element, doesn't matter. Check. In the options given to us, we have only one option which has minus 3 and minus 2. That's option B. It's minus 3 and 10, minus 3 and 10, minus 3 and 10. Only option which has minus 3 and 2 is, minus 3 and minus 2 is option B. Why would we do anything else? Nothing. Getting it? So try to identify the options and make use of that to save time. Okay. If A is a skew symmetric matrix, then A power 2021 is what? A is a skew symmetric matrix. That means minus A. You're saying A power 2021 is what? We don't know that. Take it as matrix X. Next step is what? X dash A 2021 dash. You know the property, we can take the powers later. So A dash to the power 2021. What is going to be A dash value? Minus A. Minus A power 2021. The number 2021 is odd or even? Odd. Odd power means sign will be negative only. So minus A power 2021. I'm getting this value as X dash equals to basically minus X. X is power 2021. Minus A 2021 is minus X. How much is that? What is that? Sorry, option is D. Skew symmetric matrix. Option is D. Skew symmetric matrix. Okay. Acha guys, this session is very important, right? This session is very, very important because we have done all the theory part, discuss the properties, discuss the questions, discuss board questions, CET problems. But this becomes fruitful not just by watching the session. If you're just watching it, no, yes, it might help you out. You might understand these things for a while, but you'll not remember it. You'll not be able to apply it properly. And for that, we have come up with a solution. It's called as AIO, all in one platform. All in one platform. How it works? This is the very next gen learning platform beta for all of you. This is the next gen learning platform. What you do in this is basically you first, of course, watch your lectures. Whatever lectures are there are available in the AIO platform. Okay, and later after watching this lecture, what else you're going to need? The notes. So the class notes will also be provided in this lecture. Apart from that, what else you need? You need, sir, next step will be doubt solving. That also will be provided with our own, artificial intelligence called Ved. It helps a lot, solving your doubts. After this as well, okay, what else you need? Question practice tests. So all this will also be provided in our platform itself. That's why it is called as all in one platform. This is a all in one platform, and this is all beta given to all of you for free. Just check in the link over here in this video description. Free ACE, you'll find the link for free ACE 2027 course. Click on the link now and simply register yourself by creating a login credential and start using the platform for your better understanding and learning. Clear, right? Everyone is clear about it, how to use AIO page? Got it? If you are already watching from the beginning, I've given you information about that already. Matrix is this, A plus B given over here. A is a symmetric matrix, B is a skew symmetric matrix. Then find the value of B. They're saying this is the matrix, let's say X. X is equals to what? A plus B. They're not given this. This is equals to A plus B. They're saying B is skew symmetric and A is symmetric matrix. They're asking us to find the value of B. We just learned right now, B will be X minus X dash by 2. So find X already we have. So find X dash will be what? 2. Sorry. 1 second. X dash, right? So you're going to do 2 minus 1. This is 3 and this is 5. This is X dash. Now subtract them. Keep 1 by 2 outside. 2 minus 2 is 0. 3 minus 5 is minus 2. 5 minus 3 is 2 and minus 1 is 0. Answer becomes what? Matrix B is coming as, sir, 0 minus 1, 1 and 0. 0 minus 1, 1 and 0. My option will be what? Option D. Please check. Answer is option D. Okay, cool. Next. Just last 2 questions. Come on. If a matrix of order 3 cross 3 is given, yeah, this is direct property based question. You will love it. This is already there in your property also, and this comes directly A minus square. So whether you take inverse square or square of inverse, answer comes same. So option is what? A inverse square. That's option D. We'll learn more of this in the determinant chapter, but since one of the questions are over here, I would like to solve it here as well. This is the equation wala question. We need to find the x and y value. So check over here. We have the first equation as 3x plus y equal to 15. Another is 2x minus y equal to 5. 2x minus y. Add them. Y and y cancels. So 5x is 20. X is what? 4. You add them. 5x is 20. X is 4. If x is 4, sir, it will become 8. We have 2x minus y equal to 5, right? Move on this side and this side. You have 8 minus 5 equal to y. plus 3. So x is 4, y is 3. Option B is correct. X is 4, y is 3. Okay. So this is the question. Yeah. So this was the last question for this class today. I've discussed all the varieties which is possible. If I missed something out, do let me know in the comment section. Okay, and I've tried my best to deliver everything that you need for all the topics, all the sub questions which is possible in this particular chapter, matrices. Of course, this is a very simple chapter, but still, first few chapters are very simple. First 4 actually till determinant. After that, the questions will be really challenging in nature. So let's try to cover up this first, and then we'll move on with our calculus part, high scoring but little challenging in nature. Okay, so let me know how you felt about this session in the comment section. Any doubt you have, anything you want me to improve on, give that feedback in the comment section. I'll certainly work on that. I'll certainly help you out in the best way possible. That's all in this class today. Again, I'm reminding you, go and check out AIO page. Link is given in the description. Free ACE 2027 course. I think, yeah, that is the link. Okay, free ACE 2027 course. Just click and register now and start learning free, and in the best way possible with us, same as what you're learning in YouTube, but with much more features, right, for all of you. That's all in this class. I'll see you in the next one. Till then, take care. Bye bye. All the best.